start recording here. Yeah, are you guys able to see my screen from your end? I think someone can just confirm that. Yeah, I think you guys are. So let's just go through the theory part of a priori algorithm. And we are saying that a priori algorithm is a machine learning algorithm that is used to gain insight into the structured relationships between different items involved. It is a data mining technique that is used for mining frequent item set and relevant association rules. And I'm giving an example there whereby I'm saying that recommending product based uh, on your purchased item. So you can see this in different e-commerce websites. Yeah, I'm hoping that you guys have interacted with some of these e-commerce websites, such as maybe Gigi, no, not really Gigi, but Jumia and others. So we are saying that things that we need to know before maybe even the implementation of this a priori algorithm. The first thing is the association rule. And the association rule identifies the frequent patterns and association, that is the relations, among a set of items. So let's say if you go to buy a keyboard, you might also get a mouse. So place them aside in your market to make more profit. Like in this case, we're just saying that let's say you are going to maybe even in the e-commerce platforms, maybe to buy a to you want maybe to buy a keyboard. So some of the things that might when you search maybe for a keyboard, some of the items that you might also see show up. It's gadgets. It's items such as mouse, and even this happens when it when like you go to maybe a supermarket. How things are arranged in the supermarket. They don't do that arrangement just ile kubahatisha, but it's it's from what most of the guys maybe buy that maybe influence how items in the supermarket are arranged, such that maybe if maybe if you have 100 people buying keyboard, and also maybe say 60 people buy a mouse, you notice that there is a high probability for maybe someone buying a keyboard to also purchase a mouse. So you end up placing the items. You end up maybe placing those items together. Maybe you're placing them together. That is what we are talking. That is what we are talking about when we say association rule. So the other thing is the support. So the support refers to the default popularity of an item and can be calculated by finding the number of transactions containing a particular item divided by a total number of transactions. I think that is just maybe simple mathematics where we have support, let's say keyboard. We take the transaction containing keyboards and we divide that by the total number of transaction. The other thing is that we need to check is something we call confidence. And confidence refers to the likelihood that an item B, in this case mouse, is also bought if A, if item A is that is, in this case we are talking of keyboard, is bought. So that likelihood, you can measure it in terms of percentages. So if maybe item B mouse is bought, the likelihood of item B being bought when an item A is purchased. So there is also how we do the calculation of that, and we are saying that the confidence uh, keyboard, that is keyboard implying mouse, we say that it's the transaction containing both, that is keyboard and mouse, we divide by the transaction containing uh, the keyboard, just to check the likelihood now for the likelihood of mouse being bought when an item A, when the keyboard is bought. There is also something we call lift, and lift refers to the increase in the ratio of sale of mouse when the keyboard is sold. So let me repeat that. Refer to the increase in ratio of the sale of mouse when the keyboard is sold. And this can be calculated by dividing the now the confidence of keyboard implying mouse divided by the by support. We have already seen how we calculate the support, and we have already seen how we calculate the confidence. So now it's confidence you divide by the support. And those are some of the basic mathematics that are used in these algorithm. But maybe you can just take your take your time. You go through these the theory part, and also check what you're going to do. You're going to do today. Uh, so I think you can just have let's have an implementation. And I think there is a data set that did I share this data set with you? I'm not sure if I did, but let me check. I think I shared a different data set. Just a minute. Let me share that data set with you. It's called the MBA. I think you can just load that data set very fast. Yes, there is that data set that I've shared. I think you can just download it and also upload it. So you can just create a file and call it a priori, maybe implementation, and we move now together. So the first thing that we're going to do is importing the necessary packages. And in this case, we just need the NumPy. We also need pandas, and we need frequent patterns. And this one, and we need the a priori algorithm, which we are going to get that one from something we call the MLX dot frequent underscore patterns. And also you are going to need association rules, and also you are going to import that one from the MLX dot frequent underscore patterns. So these are some of the repositories that where we are going to get the a priori and the association rules. So after that, I think you can just run that very fast, and you notice that we don't have any problem. So after loading the necessary packages, we just get into downloading our data set. In this case, I'm just reading data from a CSV file. Uh, and this is the CSV file that I've shared with you. That is the MBA. So you can as well as load that data set and even try to. You notice that I'm calling it my retail data because it contains data related to this is data from an e-commerce platform. So what you expect here is maybe the items that are bought on retail. So we are going to see so many items here. So you can just confirm that you have your data set in place. And I think I can just explain what we have. We have things like the champ, we have almonds, we have avocado, vegetables, mix, we have green grapes. There are so many items to be bought in that platform. So we have items such as low fat yogurt, we have green tea, honey, we have salad, there are so many items. So I think if you're able to read that data set, we can just get into some data preparation. And maybe before even we get to data preparation, I think you can just check the shape of this data set. I think we can have my retail, the shape. And you notice that we have so many items here. We have around we have 7,500 entries, and we have 20 around 20 columns of items to be bought. There are so there are so many items. There are like 20 of them. But let's just get to some data preparation before we use the our data in the a priori algorithm. So this is just kind of data cleaning, and you're just going to remove spaces from the beginning and the end of description. You notice that. Let me just show you that. We have a column for description. And we just to make sure that we don't have those white spaces either at the beginning or at the end. And how we do that is just doing just we have a function in Python that is called strip. Uh, the function will enable us to strip white spaces before and after that, before and after the description. And this is how we implement it. We just take your data frame, which is my retail data. You specify the column. The column is description, and then we have the my retail data again. You specify the column, and the description of is of type string. So we just do a strip. Then we just use the strip to remove the spaces from beginning and the end. So the other thing is to remove duplicates, and every item here has an invoice number, and invoice number should be unique. So we just want to make sure that we have removed all the duplicate invoices. And I think by now you guys know how we do that. We just use the drop in our function, and we are running that in our invoice numbers. The other thing I think we should do with this data is to converting the invoice numbers to be a string. That is to be a series of strings. So I think I didn't mention something we call casting when I was introducing Python. Uh, but it's just quite easy. We have you can just take you can just specify the column that you want to convert to be a string. That is our invoice number, and then this one is equals to my retail data invoice number, and we want to have that one as type of string. So that is where you can see I'm using as type, and then I'm passing in that function. I'm just passing the str. So if I wanted maybe to be an integer, I would have passed int. The other thing that I feel is necessary with this data is to remove the credit transactions. And how we do that is just quite easy. Uh, because I'm just going to run through the invoices number, and if the invoice number has container C, how this invoice numbers is generated. If it is a you notice that if items are bought on credit, you're going to have a C somewhere in the invoice number. So we just check if that invoice number contains contain a C. And if it has a C, we just want to do away with that, and that is why we are we are just removing that with that. So I think you can just run through this, and we have a problem here. Let me see. We have an error here. Let me check. Maybe you can just do some. Let me see what we have in these columns. It seems as if we don't have description column. You can just do away with this.
Hello, James.
Yes, hello.
There are some of our colleagues who will wish that you allow them to join.
Okay. Let me check that first. I think that is sorted. So we were checking this. What error are we getting? We're getting. Oh, let me see this data claim. Does it mean in our data set we don't have um, can I see this data set I'm using here? Just a minute. I think I was using a different data set. Let me just load the data set from archive. It is a large file. Let us just give it some time to load. So I think we have it now. Yeah, let me share the let me share this link. Yeah, this is where you're going to get the data set, because I just know I had just tried to clean this data set, but it seems I saved the wrong data. So let me just share this one in the message, in the in-call messages. I think you can just copy the link from the in-call messages. Yeah, I think that is it. So that now we can have the invoice number, we have the stock code, we have the description, we have the quantity of the item bought, the invoice date, the unit price, customer ID, and we have the country. So I think with this now we're able to use that data set. So let me just uncomment this. I think we should be able to run that without an error. So that was the part of data cleaning, removing the spaces from the beginning and the end of column description, dropping the null values in the invoice number, also converting the invoice number to a string, and also the last thing to remove all the items that are bought on credit. So I think with our clean data set now, we can just move to, let's see, in this column country, we have a number of countries here. And let's see the count, the value count for each country. And you notice that we have, before even we get to the count, let's just check the shape for this now. So that you can see the number of entries that we have. You notice that we have,
James,
yes,
how are you?
I'm fine, thank you.
Yes, Valentine speaking. Now, the file you've just sent. Sorry, I've joined a bit late.
Yeah.
The file you've just sent.
Mhm.
Are we uploading it to where are we uploading it?
Yeah, Mariwa. How many times have I called your name?
3 times.
3 times, huh?
Sorry.
You
Sorry
have
about that.
joined late, but there is this link that I've shared with you guys. That is the in-call
I've seen
messages.
it.
Have you seen the link?
Yes.
That is the link with the data set that you are going to use in this class.
Okay.
Yeah, and you notice that it is an Excel file. So you're going to use the read underscore Excel instead of
So
CSV.
this is my retail data. Okay. Okay.
Uh,
Sawa.
So you can just read through that. We have Dickens Okoth.
Yes, sorry, nimejoin late pia. Can you please resend the link because I'm not seeing it in the in-call messages.
It is in the in-call messages. Okay. Let me share it once more. Or I can share it in the WhatsApp group. I think that one will be easier. I think you have it in the WhatsApp. You can read that file, right? But I think you can just follow what we are doing here, and then you are going to implement these on your own later. So we have seen that we have so many entries here, and that is why it took time for us to read this file. So it might take much longer time depending on the strength of internet that we are using. So you notice that in here we have around 500,000, 532,000, and 621 entries, and we have 8 columns of data. So, and that is why we are just checking the count per country, so that we can at least use the country maybe with the most reasonable maybe number of entries. And in this case, we are going to use Germany, because if you use the whole data set, it might take us time while reading these all these entries. So we are just going to specialize, or specifically we are going to use the Germany data. So let me just show you how you can just pick up a subset for all these data, and the subset will be of Germany data. It's just quite easy. You can see we have so many countries. So let us just separate the transactions for Germany, and it's just quite easy. And I'll call that my basket. And in this case, I just want in my retail data, I just want to pick data where country is equals to Germany, and I want to group that by invoice, the invoice number, description, and the quantity. So those are the columns that I'm going to have. Also, I'll also do the sum. I'm also going to do the sum. And if now I can just do my basket dot head. Let me just run through this so that we can make sure you don't have any error. Let's see the file that we have in the basket. You notice that we have the description. We have the description here. We have the invoice numbers here. It's a large file, but I think we are going to use it. For the invoices number, you notice that also we have the invoice numbers, and also you notice that we have so many zeros here. We have so many zeros inside here. So these zeros just mean that whenever you see whenever in an invoice, each invoice number has a number of items that are associated with that invoice number. So, and where you see 0.0, it means that it means that that item was not bought. Because if you were to check here, we just have the description for an item. Like the first one here, we have a color Spaceboy pen. So it means that in this specific invoice number, we don't have that item, but maybe we have a different item in that invoice number. So I just want us to convert this data in a way that it can be consumed by our a priori algorithm. And how do we do that? We want to convert all these numbers in terms of zeros and ones, so that where we have 0.0, it will just be represented by a 0. And where we have a value greater than 0, we just give it a 1. And that is what we are doing here. So we are just I'm just encoding my just want to encode my units here. So I'll just create a function that will go all through this data. And if x is less or equal to 0, I just want to return a 0. If x is greater or equal to 1, I just want to that value just to be indicated as 1. So, and that is why I have just this function. I'm just calling it my encode unit x. So I think that is it with my function. This one will be responsible for converting all those values that are greater than 1. We give it a value of 1, and those that are equal or less than 0, we give it a value of 0. That is the data that now we are going to pass in our priori algorithm. So in here I have my basket sets, and I'll have my basket set whereby I'm saying that my basket set dot apply map, and then I just want to pass my my encode units. My encode units, it means that I'm just passing all the values, all the 0 and 1 values in my basket here. And yes, in my basket. So the next thing that I'm doing here, I just want my basket sets to drop all these to remove the postage as an item. So where I have postage, I want to drop that, and that is why I'm just doing my basket dot drop and then postage. In place is equals to, so meaning that where I have postage as an item, I'll just have to drop that. So with all these, having now converted all my data to ones and zeros, I think I can now go ahead and train my model. And this model, the a priori algorithm, is quite different from the other the other algorithms, because you notice that we need to encode our data units into 1 and zeros. So that is the simplest form our priori algorithm can understand. So let's just go ahead and maybe just try to generate frequent item sets. And how do we generate frequent item sets? So the frequent item sets, these are just sets that contains maybe items that are bought regularly in our in our data here. And that is why I'm just having the my frequent item sets. I now use my a priori algorithm. And what am I passing in my a priori algorithm? What arguments am I passing? The first argument will be now my simplified data, which is my basket sets. My basket, just take basket sets as a, you understand that when you get to a supermarket, you always pick a basket where you are going to put all maybe a trolley whereby you are going to put all the items that you want to buy. That is what we are trying to do here, having different types of basket sets from our data. So, and how we determine the a priori algorithm determine that you have this item and not this item. It will be able out to know that through these my encode units, because we said that in our description here we have all the items. They are all here. And if maybe an invoice, we just take an invoice number to represent maybe that one basket. So to determine the items that will be on the basket, it will be presented as 0 or 1. So if we have maybe 10 carrier space boy pen present in the basket, it will be presented maybe as 1. And if you didn't pick that, it will be represented as 0. That is why we are converting this so that it will be easier for our priori algorithm to understand that. So let's generate the frequent item sets. So we just need to have a priori algorithm as we pass this argument for my basket sets, and then the mean underscore support. We are just giving it as a value of 0.07, and we just want to use the column names. That is why we are just passing it as true. You can just run through this very fast. Now these my frequent item sets will enable us to generate these rules that we said here. The association rule, whereby we said that association rule, it identifies frequent pattern and associations among a set of items. So we need to generate these rules from our frequent item set. So let's go generate those rules. And how we generate those rules is just quite easy, because now you're just going to pick my rule is equals to association underscore rules, and then we just pass the frequent item sets. And we want to use this metric of lift. What did we say lift is? I think you can just go back to the definition. And the definition, we are saying that lift, it refers to the increase in the ratio of cell. In this case, we are just dealing with a mouse and a keyboard. So we are saying it refers to the increase in ratio of cell of mouse when a keyboard is sold. And the same applies with our items here. So we just want to use that metric. That is what will determine the ratio at which maybe one item is bought when the other item is bought. We are also passing an argument for mean threshold is equals to 1. So the mean threshold is equals to 1 is this one that we converted here. If x is greater than or equal to 1, That is what we are just passing as our minimum threshold is equals to 1. So I think we can just run through these very fast, and you notice that we don't have any error. And now we have our rules. Maybe we can see the rules that have been generated by let's just see the association rules that have been generated. The first 100. Let's see that. We have new terms here. The antecedents, we have the consequent. But I just need us to focus on where we have confidence. I mean support, confidence, and lift, because this is what we have already defined. That is the support, the confidence level, and also we have the lift. So, and maybe we can just focus on this rule here, whereby we are saying that the Spaceboy Launchbox, and we have a round snack box set for Wonderland. So we have these two items here, and whenever a person buys a Spaceboy lunchbox, the likelihood of him or her buying the round snack box set for Woodland, you can check the confidence in that, which is very high. It's 0.68, which is around 68%. So there is a 68% likelihood of someone buying lunch Spaceboy lunchbox to also purchase these round snack boxes. So I don't know if we are making sense here, because we said that confidence refers to the likelihood that an item B is also bought if item A is bought. So what we are trying to compare here, we have two items here. We have a Spaceboy lunchbox and we have a round snack boxes. So we are saying that the likelihood of a round snack box set being bought when this Spaceboy lunchbox is bought, we have the confidence as 68%. So meaning that we can maybe do a recommendation. We can do a recommendation, and we say that maybe in the shelves that has this Spaceboy lunchbox, maybe we can also place the round snack boxes, maybe just next to these. Or in case it is an e-commerce platform, maybe someone buying a Spaceboy lunchbox would also, we can recommend a round snack boxes. So, and that's all about now the Apriori algorithm. So I think we can just go ahead and maybe make some recommendation. Let's see how we make some recommendation. So let's see in our basket sets the number of times this round snack box is set is called for Wonderland is appearing independently on each and every basket set. And that is why we are just taking my basket underscore sets. Then we just pass in our item. We need to do the summation. So I think having done that, we are seeing that um, that in those baskets, in our baskets here sets, we have these item appearing 112 times, right? Let's see the my basket sets. The sum of the Spaceboy lunchbox appearing. We have it appearing 47 times. So in here we have so out of how many out of our basket sets, we have 112. We have these round snack boxes appearing 112 times, and we have this Spaceboy lunchbox appearing 47 times. So meaning that we can make a recommendation that we can make a recommendation such that whenever maybe someone buys a round snack box, maybe he could maybe also be interested with buying the Space Boy, or the vice versa. Maybe someone interested with buying the Space Boy lunchbox would also be interested by buying these round snack boxes, simply because our analysis here is telling us uh, through this algorithm we have at least 68% showing us that a relationship between the Space Boy lunchbox and the round snack boxes. So, and that is how the a priori algorithm works. That is the just trying to get the relationships between uh, items that are maybe in the e-commerce platform, and even just trying to get the relationship of items bought. Uh, I think that is that. I don't think it's quite difficult to understand that. But again, it requires you to go through it again at your own free time, and maybe just try to understand these things. That is the algorithm itself, and how it is used to make some recommendations. So do we have any question? I said it wasn't a walk in the park with this algorithm. But I'm hoping that you guys you are understanding what you're trying to say here. So do you have any question? Any question? Anyone who needs maybe clarification on something regarding a priori algorithm. But just to make a point of understanding this, whenever you go through when you go through this theory part of it, and understand what is lift, what is confidence, and what is support, and association rule at length, I think it will be easier for you even to understand the implementation that we have here. You can also try this one with different countries. I think we have a question. Someone is asking us to repeat. I don't know what we are repeating. Can you be more specific on what we are repeating? Let me see that. Can you repeat the making a recommendation part? That is Nathan Kiprop. Okay, someone is asking. We repeat where you are just doing the making a recommendation part. So we are recommending. We are just like, okay, we have this rule here. That we have these items. That is the Spaceboy lunchbox, and we have a round snack box set. I think of a four Wonderland. I think these are two. These are two types of lunch boxes. We have a Spaceboy and we have a round snack. And through our algorithm here, I said that I just want us to check the confidence part, because we said that the confidence refers to the likelihood of that item, an item B being bought if an item A is bought, right? So we just decided that to check in our basket sets, how many times is these round snack boxes appearing in the baskets sets that we generated. And we notice that it is appearing 112 times. We also checked the number of times the space lunch box, the number of times these Spaceboy lunchbox is appearing in the baskets that we generated, and we notice that it is appearing 47 times. All right. So meaning that out of these 112 appearances of these round snack boxes, we had at least 47. We had at least maybe 47 of those baskets having also these Spaceboy lunchbox, right? And what is the recommendation that we are saying from our algorithm? We are told that anytime when someone buys a Spaceboy lunchbox, the likelihood of these round snack boxes being bought is at least 68%. Right? So anytime the likelihood of these being bought, these round snack boxes, the likelihood for it to be bought when this one is bought is 68%. So we are just making a recommendation saying that we can recommend we can recommend recommend all the customers for who buy these Space Boy lunchbox also to maybe to consider buying the round snack boxes also. That is the kind of recommendation we are trying to do here, because our algorithm is at least telling us that the likelihood of this item round snack box being bought, if this one is bought, it is a 368 percent. We have that confidence, and so we can confidently maybe recommend all the customers for this to maybe even consider buying these. I think that is it. We have also other rules. I think you can just check the other rules. Even this one is making more sense, where we have at least the confidence level is at 83. It is at 83%. So whenever a round snack box is set of four fruit is bought, we have whenever a round snack of four boxes set of four Wonderland is bought, if this one is bought, is at least 83%. So you notice that there is that relationship between these two items. So, and I think that is it with a priori algorithm. I think you can also go and check what we meant by saying association as a category for unsupervised machine learning. So, do you have any other question? Well, maybe you can move to the next thing.
Okay, James, I wanted to understand if could this information be informing why we have periodic offers in supermarkets or even Black Fridays for Jumia and Kilimall, so that they can be able to move some stocks?
That one, we have a number of reasons why we have that. We have a number of reasons why we have maybe we have those overs, because we have a number of reasons, but with this one, we are just trying to do a recommendation. But also this one, even although it's not maybe a large percentage of the reason why we have those offers, but also it plays part, because you notice that whenever maybe let's say that this item is moving at that rate, maybe at a certain rate, and you notice maybe when someone it's like we let me just give you an example here. Just assume maybe in let's say that you have this information, and let's assume the item in place here is maybe something like what, let's say something like maybe it's a supermarket, and maybe we have just trying to think of an example of maybe items that can be related. So let's assume that item A heavily relates with item B. So maybe giving offers for maybe item B will will maybe cause people maybe let's say will maybe it will happen that whenever maybe we give offer for an item B, and the item B is heavily related to or has a direct, maybe has a high relationship between has a high relationship with A. So whenever we give an offer on item B, it will consequently lead to people buying item A. I think basically that is what happens. So if you have maybe that information, like let's say in this case where we already know that uh, whenever maybe whenever someone buys a Space Boy lunchbox, 68% there is that 68% confidence that he's likely maybe to buy this round snack box, right? And so it means that uh, giving an offer on this space lunchbox will consequently lead to maybe more purchases on these, maybe more purchases on these round snack boxes. I think it's all about mind game. When you do analysis on this data, you tend to understand a lot of you get a lot of patterns that that relates between items. So it's not really something that someone wakes up and say that we have an offer on maybe maize flour and or maybe we have an offer on rice. It's all about understanding what they have in the patterns they have in the data, and knowing that maybe giving an offer on one item will lead to another item being bought, even if it doesn't have an offer, because maybe either way it relates to the item with an offer. So there is so much to learn whenever you have these data, and a priori algorithm will help you to understand the association between items, so that maybe you can make a recommendation. In fact, what we have in supermarket, these are kind of the recommendations that maybe we these are this is a part of recommendations that we tend to give whenever maybe you do analysis on these baskets. So we say an item, we can give an offer on item A, and giving an offer on item A will maybe lead to item B to be bought. It's all about, those are kind of recommendations that you get whenever you do analysis on these basket sets. I mean, yeah, I think that is it. So just take your time and just try to understand these algorithm. Just take your time. You can try out with a different country, because this one is just for, I think we have more than 15 countries, but I just chose Germany. So you can just check uh, data for other countries, so that at least maybe you can come up with a maybe a recommendation system through this algorithm, and you notice that those are some of the systems that you can sell at good price. So we have more than 15 countries here, so you can just try to pick several. In fact, you can work with the UK. It has a lot of data here. I think you have 487 487,000 entries. You can just try to work around these and see what you can come up with. So I think The next thing that I wanted us to check is how you can save your model and even maybe share it with your friend, or maybe use it somewhere else. And I think you can just do that with a very simple model. I think I just try to check what I have here. And I'm hoping that you guys also checked the k-means. I think I shared the file yesterday with the k-means model. I think it's just right here. I think the problem was on I think I didn't run all the cells. That is why you are getting some issues. So let me just run through this very fast so that you can see how you can save your model in a file. Hoping I have this data with me. Let me check. Oops. Let me upload this very fast. These things are interesting, by the way. You can just come up with something useful with what we have been learning. I think I had, let me see this. Where did I place that data set? Maybe it should be in download or something. Oh, it's here. Oh. So I think we have it. So let's just run this through very fast. I'm hoping we don't have errors. And that one is okay. Let me load the data set. The scatter plots. Then we have these clusters. Let me do some pre-processing. Then we have the PLT scatter. KM is cluster centers. We have these. Now below these. This is where I want us to save our model as a file.
Now, James,
Yes.
now, are you going to share with us all this so that we run by ourselves?
This one. I think I shared this one. The k-means clustering. I think this is a file that you guys have.
Okay.
But I'll also share with you the what we have just done right now, that is the a priori. The a
Yes,
priori
that
file I'll
we can
share with you. Yeah,
also
and even the theory part of it. Sorry?
run on our own, so that we can run on our own to understand.
Yes, yes. I'll share with you.
Okay.
Even the theory part of the a priori I'll also share with you. So
Thank you.
whenever I talk of saving our model as a file, think of how this chat GPT works. Like we have a whole trained model working in a website platform, right? So that is basically what we want with our model. Let's say you have created a model like this one that we are using our model to do some. I think this one doesn't. This one can't be used. Um, let me just try and I need. Let me just try and find the regression model. I think we made a very good regression model sometimes back. So that you can at least understand these. Yeah, I think this one was the this one is this one is a good example because this one we were using it to predict prices of a home given an area. Yeah, I think this one was a good example. Let's just try to save this model. I think I can just, I don't know if I have that data set. Let me just try to look for it. Now the 5, 6. I think I had that data set here. Yeah, it's just right here. So let us just load these very fast. This is the model that we did to predict house prices based on the area that the house occupies. Let me see this. Can run all through these very fast. In regression, you have even the before now these. I think our model had a score of around 95%. So now below these, let's say now you have created that model and has this score, right? And I want to share all what you have done now to maybe a person, so that whenever he just maybe uses that model, he can just pass some values and maybe uh, get the output. So how do you do that? We just have to save this model as a. Oops, let me just fix this. Make it okay. So we just have to save this one as a file. And how do we do that? It's very simple. We just import something that is called pickle. You just have to import pickle, and then we say that with open I just want to name our model as a model pickle, model underscore pickle, and we want us to write something. So we are opening this file as a we want to write some binary in that. So just W means write. We write binary. We want to write some binaries in this, and we want to do that one as a file. So this is how we do it. So there is this function that is called dump. We want to dump all what we have done into a file. So how do we do that? It's just quite easy. We just call pickle. It should be pickle, not pickle. Pickle. Think dot dump. It's called dot dump. Na si ile ya kuachana. Ni ya kudump kitu hapa sasa, ya kudump that model. We want to dump that model in here and you want to dump that thing as a file. So I don't know how you are getting this. I think, let me see, unexpected indent block. Yeah, we should have an indent here because this one, let me see. Yeah. So what is the name of our model? Our model here, I think we call it, let me see, what name did we give our model here? Yeah, we call it linear regression object copy. That is what we want to pass here. I think that is it. So with open, I think we have it as this. I think it's just okay now. This one is saving the model. Let's see how now we use the saved model. It's just quite easy. Again, we just have now to open this we just have to open this file, by the way. With open, what name did we give our model? We just call it model underscore pickle. But this time round, now we want to open in read mode. I want to read the binaries, and you want to read these binaries as a file, as F. And just use as F, not file as F. And now we have, I think we can just have this one. We can have maybe saved model underscore model is equals to pickle dot load. Need to load this. I'm hoping I'm getting the right syntax for this, so that we don't have errors. And in here I just have to pass F. Oops. Let me just try to run these and see if we have errors. Oops, we have an error here. What is it saying? Pickle is not defined. It's supposed to be pickle. Pickle. Don't know how to pronounce that. Let's run this. So you notice at first you are using the linear regression underscore object to predict these, right? And if you were to predict these, you're going to get this value. What if now we use, let me just be raw here. I use the saved model, saved model dot predict. And what do I want to predict? That is a house with this area. We just try to run this. And now you notice with the saved model now, we have it the linear regression object. It gave us this value. And now with our saved model, it's also giving us the same value. So meaning that these let me check if this file has been saved in my let me check that it should be saved somewhere. Let me check. Maybe saved somewhere. Okay, let's see this again. You notice that here I have a file that is called model pickle. This is the file that I can download now. If I download this file, I think I should see it somewhere here in my downloads. Yeah, I think now I can have it in my downloads here. So you notice I have a file here, and now this file can be used anywhere. That is without even now having that code. Let's just try to open this, and you notice it has it's a file with a binary file, binary things, things that you cannot understand. So this is our saved model. I think you can barely read this, but this is now our file. This file can be used anywhere. So even if maybe I open I can just use it anywhere. Let me see this. This one I can use it. I can use it. I can just use it anywhere in my code, even outside this now. Can maybe just have a different thing here, and maybe call it saved. Saved what? Saved underscore model. And I just say maybe predict. Do some prediction. You can predict anything now with this. Predict. Maybe a house with that area. what you need to know is now what the value maybe of the area now, without having to rewrite that code again, because now you have a saved model. So it's all about that. So this one now can be used maybe in a website, in an application. You can share with your friend this file, and he will still use it elsewhere because it's already now saved in your. It is already trained, so your friend doesn't have to train that again. So I can share this one with you, and you will use it. Elsewhere. So I think that is it with what that is Python for data analysis, and also some part of machine learning. So yeah, that brings us to the end of our class today. Yes, and I would like to hear some suggestions, recommendations from you guys. Maybe we can have two. I like we have gender balance. We have two ladies and we have two gents. Maybe saying what how the program was, and maybe you can tell us maybe where to improve for the next cohort, and what you have learned if you benefited from the program. So yeah, as we come to the end of our program today. So I don't know who will volunteer.